we started with the Bingham Tunnel toll problem. So every time you go through, and that's actually pretty common on the East Coast, that there's tunnels that go under these rivers. Anyways, you pay a toll in order to do that, just like on 294 or on 355 or on some other areas here, you have to pay a toll. Well, normally, every time you use the toll, the cost is 50 cents, toll cost. Every time, okay? 50 cents per trip through. There is also a discounted feature available where if you purchase the sticker at a cost of $5.50, then you only pay 35 cents per. Okay? The question is, how often do you use this toll bridge? And at what point, the question says, how many trips through the tunnel are needed before the sticker costs less than paying for each individual trip. Okay? So how many pers or how many times will it take before paying for the sticker is a better value? Okay, every time you go through the toll, you're either going to pay this, ding, 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 or you purchase this, and then each time you go through. So I'm looking for the value for T that says, at this point, you need to now purchase the sticker. Okay, so like if you find out, let's just say that $5.50 deal is for only good for 1 year. And let's just say you go through the tunnel twice a month. That would be 24 times. Twice a month would be 24 times. So let's just say you know 2 times a month is your actual. Is it worth my while to pay for this sticker? Well, we can solve this right now. And I'm not sure if any of you realize that if you multiply each piece by 100, you clear your decimals. If you multiply each piece by 100, you clear your decimals. 50t is greater than 550 plus 35t. I hate working with decimals. I realize it's just a little dot, but I don't like it. If I subtract 35t from both sides, I end up with 15t. And if I divide by 15, I should find out that once I've hit 37, any toll over that would have been cheaper had I done the 550 sticker. Okay? Any toll over 37, it would make sense for me to buy the sticker. Let's go back to my original scenario. I only use the bridge twice a month. I'm making that up. Should I buy the sticker? No. No. All right? So if this were the truth, it's a no. Okay? If that's the truth. Okay. I had a weird thing happen to me yesterday when I was working through some of these. The calculator I was using like literally would not work, and I'm going to show you what it did here in a second. So anyways, question 4 says the lengths of the legs of an isosceles triangle are integers, which means whole numbers. Since they're lengths, they've got to be greater than 0. Can't have negative size. The base is 1/2 as long as each leg. The base is 1/2 as long as each leg. What are the possible lengths of the legs if the perimeter is between 6 and 16 units? What are the possible lengths of the legs if the perimeter is between 6 and 16 units? What that means is the sum of this, which is 2.5 L, falls between 6 and 16. Am I right? That makes sense? When you're given an equation, an inequality in 3 parts such as this, the easiest way to do it is to divide all 3 pieces at one time. Once you've performed that division, you end up with 2.4 is less than L, which is less than, 6.4. Mercy, she said. Okay, come on, Mrs. Myers. Divide all 3 pieces by 2.5, and here's your results. Plug it in your calculator, you'll see this is what you get. I had a defective calculator, and it told me 6 divided by 2.5 is 2, and 16 divided by 6.4 is 3, I think. Something really weird, and I couldn't figure it out. Anyways, calculator's now in the trash. So what does that tell us? If the legs aren't integers, then what can the legs be? Well, they can be 3, 4, 5, or 6. The leg length has to fall between 2.4 and 6.4. It can't be any other numbers because these are the only integers that fall between these 2 numbers. Okay? Any questions on that one? Okay. Number 6. Find all sets of 3 consecutive evens whose sum is between 25 and 45. This is going to look exactly the same as this one. Okay, we talked about perimeter, sum of the sides. Well, sum of the integers. You can think the same way. Find all sets of 3 consecutive evens, so n plus 2, n plus 4, whose sum, which is why I'm adding them together, whose sum is between 25 and 45. So the sum of this, that, and that falls between 25 and 45. So in the middle, you have 3n plus 6, 2 and 4, yep. Are you guys cool with this so far? I don't want to gloss anything. Subtract 6. 19 is less than 3n, which is less than 39. Did I do my arithmetic right? Please call me out if I don't. So after I divide everything by 3, n falls between 6 and 3/10 and 13. Now remember, n is an even. How do I know that? Because they told me these are consecutive evens. What is the first even that falls after 6 3/10? 8. My first set is 8, 10, and 12. What is my second even that falls between 6 and 13? Yep. And 12 would also work as my first value. So this represents all of the sets of consecutive evens whose first value lies between here and here, which then creates a sum between here and here. Okay, are you cool with that? Okay. How'd you guys like the test score thing? Anybody get that one? Test scores number 8? No? Okay. Might not have gotten to it. I'm going to flip. We got 2 more left to do. Number 8. You guys could use this. Jim's second test score was 8 points higher than his first. So I'm going to do scores. Looks like there's a first and a second. His third score was 88. Looks like there's a third. And they tell me the exact value. His third score is an 88. He had a B average, which is between 80 and 89. They tell me that. For the 3 tests, what can we conclude about the first score? Well, first I know nothing about the first score. But I do know that the second score was 8 points higher. Okay? And I also know that the average of these 3 scores fell between 80 and 89. Now all I need to do is add them up. Looks like this. Here's the first test. Here's the second test. And here's the third test. Remember, to find the average, you take the 3 scores, well, the scores, and divide by the total number of scores, which there happens to be 3, right? So now it looks like this. How on earth can I make this so that I can somehow get rid of that 3? Because that 3 poses a problem. What'd you say, Amber? Yes, ma'am. Multiply each piece by 3. 3 times 80 is 240. 3 times 2x plus 96 over 3, the 3's cancel out. Three times 89, 267. Now I can solve for x, and that will give me something about that value. Subtracting 96 from all 3 sides results in 144 being less than 2x, which is less than 171. Cutting all of that in half because of the 2 tells me then that that first test score is between 71 and, it should be less than or equal to, by the way. Wait, say again? 72. Yep, 72. No, it's not less than or equal to. It falls between, sorry. Should have trusted myself. Should have read what I wrote. And 85.5. Thank you. Which tells me the first test, here's your answer, is between 72 and 85.5 in order to create that scenario. Bigger than 72, smaller than 85.5. Any numbers in between. Okay, last one, number 10. An equilateral triangle, pretend this is equilateral. The three sides of an equilateral triangle, side, 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 are increased by 20, 30, and 40. So this guy is a 20 increase, he is a 30, he is a 40. The perimeter of the resulting triangle is between twice and 3 times the old triangle. So what does that look like? It's a little bit tricky, by the way. Would you guys agree with me that the original triangle had a perimeter of 3x? And the new triangle has a perimeter between double and triple the old. So double the old is 2 3x's. Triple the old is 3 3x's. The new triangle, by the way, would you agree is 3x plus 90? 30, 70, 90? Sorry. So the original perimeter is that, x plus x plus x. When we added 20, 30, and 40, the new result is somewhere between double and triple the original. Double and triple the original. Now, it depends on you. Some of you might like to solve this differently than I do. Whenever there's x's out here, it bothers me for some reason. So this is what I have right now. I've always found it simpler when you have x's on the outside as well as the inside to solve them separately. So that's how I do it. You might not. It's fine. So over here, solving for the left side, 6x is less than 3x plus 90. So 3x is less than 90. So x has to be less than 30. Am I right? Did my arithmetic make sense? Okay. The other side. 3x plus 90 is less than 9x. Subtract your x, you get 90 is less than 6x. And you end up with x being greater than 15. Which means to me, x has to fall between, it's greater than 15, and it's less than 30. X is greater than 15, which is the blue answer. X is less than 30, which is the green answer. Okay? The sides is between 15 and 30 in order to make that double, triple scenario true.